Hello, APES crew. It's Miss Lenorovitz again, and I want to give you an introduction to the lab that you're going to try out in today's class. So you've been learning about how we estimate population size, and the lab that you're going to practice with today is actually going to let you try out the mark and recapture method. In reality, you've already been part of at least a portion of a mark and recapture method earlier this year when you reared your monarch butterflies, and then we tagged them as adults as they left on their migratory route. So you did the tagging portion of this. This process that you're going to do today in the lab is actually going to allow you to experience the rest of how that works to estimate the size of the monarch population. So you're going to be using this equation here, where you take the number of individuals that was marked initially. We're going to divide it by n, which is the overall population size, and we're going to equate that to the number of tagged or marked individuals you recapture and the size of the second sample when you do your second sampling. From that, we can isolate n, or the size of the population, and solve for that. So let's take a look at the lab and a preview of the directions. All right, so in this lab, estimating population size, your learning targets are both mathematical and computational thinking, in which case you're explaining and applying the different methods to estimate a population size, as well as constructing arguments. Here, you're comparing and contrasting the reproductive strategies and survivorship curves of different species, whether there are selected species or K-selected species. The research question for this lab is, how do population estimates using mark and capture techniques compared to the true population size? So how are you actually going to approach this? You are going to have a large bag of beans, hopefully a large enough population size that you're going to be dissuaded from wanting to count each individual that's here present in a population. With that bag of beans that you have, you are going to obtain a subsample. You are going to have a small container. It might be a centrifuge too, but it might actually be a beaker. And you're going to use that container to actually scoop in and get a subsample of your overall population. From there, you're going to take all of those beans that you capture in your first sampling, and you are going to mark them with a Sharpie marker so that they have a tag or a mark on them that you're going to easily be able to recognize in the future. Awesome. So hopefully here you can see that I've marked this particular bean with an X. I would do that for all of the beans that I captured in my first capture. Once I've done that, I'm going to take all of those marked beans and I'm going to mix them back in with the original population. You want to make sure when you put them back in that they are really well mixed. So at this point now, you have done steps 1 through 3 on the procedure. We'll take a look at what you're going to do from here on out. By the time you get to step number 4, your bag should contain all of the beans it originally had, including the marked ones. So now you're going to use your exact same sampling container and you're going to go back in and you're going to resample your mixed bag. So now this is my second sample. I'm going to go through this second sample now. I'm going to spread it out in a container on my table, and I'm going to count how many beans are in this second sample, and I'm also going to count how many of those individuals are actually recaptured beans, the ones that I marked initially. I'm then going to record both of those values. So I want to know the number that I've marked initially, the number that I've recaptured, and the total number that was in the second sample. Because you're working with a team, and you would do this in the real world as well, you would repeat that process several times. So once you've done it, you're going to dump those beans back in, you're going to mix them really well, and then another person from your team is going to repeat that process. So you're going to have several averaged values for your recaptured rate as well as for your second sample. Then let's take a look at how you do your calculations. Remember that what you're trying to do is to figure out the total population size here without having to count every single individual bean. So how do we do that with your data? Well, let's say that of all of the beans that I collected initially, 100 of them were in that very first sample, and I marked them with an X or a tag. I mixed them back in, and I repeated my sampling protocol using the same size container, And in that second sample, let's say that I had a total of 95 beans. And let's say that of those 95 beans I had in my second sample, on average, 10 of them were recaptured, meaning they are the ones that have the X on them. How can I use that information to figure out the size of the actual whole population? Well, I'm going to use this equation here, and we're making a ratio. We are assuming the number that was marked initially compared to the actual size of the full population is going to be equal to the ratio of the number we recaptured divided by the number in the second sample. Again, here, N stands for total population size. So I'm going to rearrange this equivalency to solve for N. So N is equal to the number that were marked times the number that were in the second sample divided by the number that were recaptured. So when we put those values in, our number marked was 100. Our number in the second sample was 95, so I'm going to multiply those two values, and I'm going to take my answer to that and divide it by the number that were recaptured, which in this case is 10. If I go ahead and finish that calculation, my answer to that is that my population is going to be equal to 950 beans. So now we've got a pretty good estimate for the size of that population. Hopefully this helps you figure out how to do the next steps. From there, you're going to apply your thinking and draw some conclusions and link it back to the work that we did with monarch butterflies. I look forward to seeing what you come up with.